This is number 6 on the no calculator section on your test. We have like a balloon that's going up in the air, and we have a person standing 300 feet from where the balloon takes off, and we're talking about the angle of elevation and its rate of change. So, first thing I'm going to do is draw a picture. Oops. This point down here is where the person is standing, so I'll call it P. This point right here is where it takes off, so I'll call it T. And then my balloon is up here, so I'll call it B. So the B is going up. It tells me that the distance from the angle from the person to where the takeoff point is 300. So I'm going to write 300. I think we're working in feet, but I'm not going to write units because of space. This variable over here is changing. I'm going to call it y. I call it y because it's height. Notice it asks at what rate is the angle of elevation changing when the balloon is 50. So it's asking me for, well, I have to label theta first. So this is going to be my theta. So it's asking what is d theta dt equals what when y, which is this height right here that I labeled that's changing, is equal to 400. So what I'm going to do right here next to this y is write that it equals that it equals 400, because that's where I'm concerned about it. I am going to use y when I'm writing my variables out. The 300 is not changing. The person's not moving away from the takeoff point. So that 300 stays as is. So I am going to use my trig relationships. I have two things that I want to get a relationship between. I want the theta and I want the y. So if you look, y is opposite of theta, and then the 300 is adjacent. So I have O and A, so I can write an expression tan, or an equation tan of theta is equal to y over 300. So from here, I could derive, so basically we've talked a lot about you need to find your variables, you need to find your relation. There's 4 steps. You need to find your variables, you need to find the relationship between the variables. So finding the variables was theta and y. The relationship is what I have in orange right there. So then you go and you derive. You derive with respect to t. That's going to be my next step. And then my last step is going to be to plug numbers in. So for example, that's something I'm going to plug in, and we'll talk about everything else that we're going to plug in. What was the other thing? The hot air balloon is rising at 60 feet per minute. So that's actually, and I'll write it up here right now, dy, because it's rising at that rate. dy, it's hard to write at the top of the screen, dt is my 60. So those are the 2 things that I'm going to plug in once I get the relation. But so I could derive this as is. I don't like the 300 where it is, so I am going to multiply by 300 on both sides just to not have fractions, and I get 300 tan theta equals y. So from here, I'm going to actually bring my work over to this side. I want to derive with respect to t. So maybe I'll change colors since now I'm going into the next step. So each of these colors kind of represents a step in the whole process that we've talked about quite a bit in class. So when I derive that, and remember I'm doing with respect to t. So I get 300, it stays there. This tan theta right here, when I derive it, I've got a guts rule there, need to derive tan theta. That gives me secant squared theta. And then I have to go and derive the inside. I've done the outside piece, I need to derive the inside piece, which is just the theta right there. So the derivative of theta with respect to t is times d theta dt. The right hand side is super easy to derive with respect to t, it's just dy dt. If I had y squared, it'd be a little bit different. You'd have a chain rule in there. But I get dy dt like that. Okay. So from here we need to, so that's my third step, right? First step was purple, find the variables. Second step was orange, find the relation. Next step is blue, we derive. So I guess I will change colors again. I now need to plug my numbers in. So this is the guy that I'm looking for. Sorry, I forget where I was. I know the d theta dt is what I'm looking for. I know this value. That is 60. So I'll make a little arrow. That's 60. I actually don't have to use the y equal to 400 in this equation. It doesn't actually show up, well, it doesn't show up as y anywhere. Here's the deal though. This secant theta, or secant squared of theta, secant is hypotenuse over adjacent. So, what I need to do is plug in hypotenuse over adjacent squared. So if I come over to the picture, this is where I actually use the y equal to 400. As I come over to the picture, you should notice that, I mean, this is a non-calculator question, right? You should notice that I've got 300, 400. That's a 3, 4, 5 triangle that's multiplied by what? Yeah, that's right, 100. So that makes this side here 500. So that's my hypotenuse. So now, and my adjacent is 300. So now what I can do, instead of trying to like find theta and then do secant squared of that angle, I am just going to use the triangle to find what secant squared is. So let me rewrite everything. 300 shows up first. Secant squared theta. Well, secant squared is hypotenuse over adjacent squared, so I'll draw a fraction. And in the top, I get this guy. So I get 500. In the bottom, I get this guy. It's 300. And they both need to be squared. So I'm going to square and square like that. That's times d theta dt, which is what I'm looking for. And it's equal to dy dt. dy dt, remember, is 60. So this one, I think it's the first 3 steps aren't bad. It's the third step, and really the crux of the third step is figuring out how to get that 500. So let me scroll down. Remember, we're looking for d theta dt. So what really I have to do here is solve for d theta dt. So I've got 300 squared and a 300 here. So this is going to cancel with one of these and leave me with just 300. In the top, I'm going to have, and this is me just going through this process of trying to figure out how to simplify this as much as possible without having a calculator. So I've got, I'm going to write out the 500. If I had a calculator right here, I'd be like almost over. I would just punch it in and get a number, right? But unfortunately I don't. So I have 500 times 500 over 300 times d theta dt, which is what I'm looking for, is equal to 60. So I can cancel some of these zeros with some of these zeros. Then I'm gonna, so what I really have is 500 times 5 over 3, and I'm gonna leave it factored so that I can kind of simplify things over on the right hand side. So now what I'm going to do is I'm going to divide by that fraction, which is just multiplied by the other, by it flipped upside down. So what I get is d theta dt equals 60 times, I get a 3 over 500 times 5. So from here, this cancels with one of those. And does the 6 cancel out with anything? Yes. So the 6 is divisible. Well, I can write it out. I get 6 times 3 over 5 times 50. The 6 is divisible by 2, as is the 50. So I'm going to cancel that out and make it a 2. Cancel this out and make it a 25. Now everything is as simplified as possible. Sorry, I don't cancel it. This gives me a 3, not a 2. So from here, I get 3 times 3, which is 9, over 5 times 25, which is 125. And then we talked a little bit about it in class, but my units are radians per second whenever we have a related rate problem and we're doing sines and cosines and stuff like this. Or, sorry, d theta dt. So, hopefully that helps a little bit.